Hi, 7th graders. Today is our last math video for this school year. You're going to need your probability workbook. You're going to open it up to page 18 and 19. Ooh, tiny flex with all my pretty pens. Sorry about it, but not really. Okay, so we've got this right here. We are working through page 18 and 19 together. And we will get started right now. Hit pause if you need to get your stuff out. A stack of cards contain 9 cards shown to the right. Remember, that's our whole. 1, 2, 3, 4, 5, 6, 7, 8, 9. My bottom is 9 out of 9. Okay, so let's start. Out of 9, okay. If Ellie randomly picks on card, I think they meant to say 1. If Ellie randomly picks 1 card from the stack, what is the probability that the card is an even number? Okay, so if we're looking for even numbers, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, no, okay. Yep, those are all odds. So we've got 1, 2, 3, 3 out of 9. Simplified down, if I do it to the top, I do it to the bottom. 3 divided by 3 is 1. 9 divided by 3 is 3. Okay, so we've got 1/3. Now, if Ellie replaces the card, so she pulls out an even number, there's a 1/3 chance of that, she puts it back. That bottom, that hole, is going to stay 9. But that's what we're looking out for today. What is the probability the card is an even number? Well, she put all those numbers back, so she has a 3 out of 9 chance that it's going to be an even number. I'm going to simplify. If I do it to the top, I do it to the bottom, and I get 1/3. Now, letter C. If Ellie picks an even number from the stack and keeps it, then picks another card, what is the probability that the second card is even? Well, let's go and let's rewind back. If Ellie picks an even number from the stack, so she takes 1 even number from the stack, what's my whole? Out of how many? 1, 2, 3, 4, 5, 6, 7, 8. It's out of 8 now. Does that make sense? Because that card is gone. She put it in her pocket or whatever. So then, what is the probability that the second card is even? Well, that even's gone. So here's my 2 evens I have left. 1, 2. So 2 out of 8. And I'm going to simplify. If I do it to the top, I do it to the bottom. 2 divided by 2 is 1. 8 divided by 2 is 4. There we go. All right, so that's what we're looking for. If she's replacing it, if she's picking it and replacing it, or if she's picking it and keeping it, my denominator is either going to stay the same or it's going to change. My whole is going to stay the same or it's going to change. Letter D. What is the difference between replacing the first card and not replacing the first card? Well, when you replace the first card, you do not change the original numbers of the cards or the number of even cards. When you do not replace the first card, you change the original number of cards and the number of even cards. So what is the difference? Well, what changes? The original number of cards and the number of evens change when you do not replace. All right, letter E. Think about the words independent and dependent. What do those words mean to you? Well, if I am independent, INDEPENDENT, do you know what that means? Oh man, that song used to be popular. He's talking about an independent woman. She doesn't need a man, right? Independent means you do not rely on anything else. Does not rely on anything else. Oh, when Tish and I get into an argument, I say, I'm an independent woman, right? Now, dependent is something that it means you rely on others, right? Rely on others. So, independent. When I lived in Oak Park all by myself, I was independent. When I lived at my parents' house when I was in 7th grade, I was a dependent. I relied on others. I needed rides. I needed food, right? Letter F. When Ellie picked 2 cards and replaced the first card. Okay, that's important. When Ellie picked 2 cards and replaced the first card, was that an independent or dependent event? So she picked 2 but only replaced 1. Okay? So letter F. It was independent because it didn't. When Ellie picked 2 cards and replaced the first card, was that an independent or dependent event? It was independent because it didn't change anything for the second trial. Oh, okay, so she picked the cards 2 times, right? Sometimes I don't like the wording. So she picked 1 card, she replaced the first card, then she picked another card. It's independent because nothing changed, right? Oops, sorry guys, the bar is right in my arm. It did not change anything for the second trial. Now with this, just take a second to think through, like read it out loud and then think through and say, okay, what are they trying to say here? All right, next one. Letter G, when Ellie picked 2 cards and did not replace the first card. So remember, she's got it. She picks up the first card, keeps it, does not replace it. Was that an independent or a dependent event? Well, it's dependent. Why? Because, that's shorthand for because, it changed the second trial, right? The second trial depended, or I'm sorry, the number of even cards that we pulled was changed because it depended on what happened in the first trial. Dependent because it changed what could happen in the second trial. Okay, sorry that's a bit sloppy. I'm telling you, the bar is right here. All right. Now, independent events, dependent events. This is the main part you need to walk away with. Hey, I've got this. Okay? So, independent events. It's the probability of one event. Oh, man. Of one event. Okay? It in no way affects another event, right? The probability of one event that does not affect another event, right? The card goes back. The whole stays the same. The probability of one event in no way affects another, ANOTHER, events, okay? Because it keeps the same whole. Now, the next one, dependent events. The probability of an event, is affected. The probability of an event affects the outcome of another one. Okay? The probability of an event affects the outcome of another event. All right, we saw that up here where it changed when she didn't put the card back. All right, we're moving on to number 19, page 19. Miss Little, let me make sure I'm centered. Okay, Miss Little has 8 boys and 10 girls in her class. Okay, right now, right away, I'm thinking, what's my whole? Out of, what's my total? I've got 8 boys, 10 girls, total out of 18. Okay? Now, she picks a student each morning to take her attendance. You remember Miss Schlechter had those little popsicle sticks in her room. What is the probability she picks a girl? Well, the probability of her picking a girl is 10 out of 18. Am I done? No, I need to simplify. Divide by 2. If I do it to the top, I do it to the bottom. 10 divided by 2 is 5. 18 divided by 2 is 9. So I end up with 5/9. What is the probability that she picks a boy? She's got 8 boys out of the total of 18, right? Let's simplify. Divide the top and the bottom by 2. 8 divided by 2 is 4. 18 divided by 2 is 9. 4/9. All right, letter C. Miss Little has each student's name on a popsicle stick. What is the probability? Sorry, my phone keeps going off over here. What is the probability that she picks a girl on Monday, puts the stick back, and picks a girl on Tuesday? Okay, so that's the main thing. Does my whole change? No. So it's an independent, right? All right, so what is the probability that she picks a girl on Monday? Well, that would be 5/9, right? And then puts the stick back and picks a girl on Tuesday. Oh, guys, this is that multiplication, right? 5/9, 5/9, right? I'm pulling it right from here. So then we're going to multiply, go straight across. Numerator times numerator. 5 times 5 is 25. 9 times 9 is 81. Okay? So there's your probability that she would pick a girl on Monday, put the stick back, and pick another girl on Tuesday. Right? Because the number of girls didn't change because she didn't take that stick and put it to the side. All right, letter D. What is the probability that she picks a girl on Monday, does not replace the stick? Okay, so that's important. So she picks the girl on Monday, 5/9. Everybody was there, right? 10 out of 18 simplified to 5/9. Second one, she takes the stick and doesn't return it. So here's the main thing. Before I even put anything here to multiply, she now has lowered my whole out of 18 to 17 because she took that stick away. And she lowered my girls from 10 to 9. So I've got 9/17. Okay? So, what is the probability she picks a girl on Monday and does not replace the stick and picks a girl on Tuesday? Okay, you guys, I'm not going back because I'm already 13 minutes in. But this part right here, we don't need yet. We're looking at this one. 9/17 would be the answer for that one. Now, letter E. What is the probability that she picks a boy 2 days in a row if the popsicle stick is replaced? So that's one where we're going back to C. So she picks a boy. So we've got 4/9 on day 1, puts him back. 4/9 on day 2. We've got 4 times 4, that's 16. 9 times 9, that's 81. I'm going to move it over here. 16 out of 81. Okay, so this one right here, Miss Underhill, I think the answer and the answer guide is wrong, so I want to check over that one with you. But, letter F. What is the probability? Yeah. What is the probability? No, okay, I'm coming back to this one now. I see what they did. They simplified it. That 5/9 stays here. And we're going to multiply straight across. But what they did was they looked right here and they simplified. They took a 9 out of the bottom, and they took a 9 out of the top, and they multiplied straight across, and that's where they got 5/17. Okay? So 9/17 was the second day, 5/9 was the first day because it was simplified, right? Then they simplified before they even started. If you were to multiply straight across, 5 times 9 is 45. 9 times 17, gotta pull that cell phone out, which apparently mine has been blowing up because I'm sitting and it keeps buzzing behind me. So 9 times 17 is 153. Then, if I do it to the top, I do it to the bottom. To simplify, divide by 9, divide by 9. 153 divided by 9 is equal to 17. Okay, there we go. Whew, 45 divided by 9 is 5. All right, that's where we get that answer. All right, I'm getting it now. I'm feeling okay. I hope that you are too. All right, letter F. What is the probability that she picks a boy 2 days in a row if the popsicle stick is not replaced? Here we go, not replaced. So she picks a boy on the first day, 4 9s. Where did I get 4 9s from? It was the simplified version of 8 boys out of the whole class, 18. Now, she does not replace it, so my denominator becomes 17. Now, if I got rid of one boy, I didn't put it back, my numerator becomes 7 out of 17. All right, now we're cooking. Now we are cooking. So I pull out my cell phone. I've got 17 times 9. I'm doing my denominators first, straight across. 17 times 9 is 153. Then I do the top. 4 times 7 is equal to 28. Okay. Whew. All right. We're feeling okay. Cannot simplify. All right. I'm better now. Letter G. Explain which of the events in the situation above are independent and how you know. Oh, okay. We've got this. Remember, independent means that it doesn't change the next event. So it doesn't make me have to go up here, take one out of the whole, take one out of the numerator as well. So independents are when the sticks are replaced, right? When the sticks are put back. Okay, that's the first thing. The events are independent because it didn't affect my second pull. All right? Really and truly, it's when you don't have to do as much of this extra math, right? Okay, second one. Explain which events in the above situation are dependent. Okay? So if we're looking at dependent, right? It means that the probability of an event affects the outcome of another event. So if we're looking, all right, well, I'm going to tell you right here. Does not replace the stick. That changed the second one. Does not replace. Is not replaced. That changed the second one. So when the sticks are not replaced. I am hoping you guys are working through this with me and you're feeling like, oh, okay, all right, now we got you, Miss Washburn. Number 3, Roman numeral number 3. Lily is playing a game with a stack of cards. In order to win the game, she must pull 2 of the same cards in a row. If Lily wants to have the best chances of winning, she should replace the first card that she picks, or should she keep it? All right, now, she's playing a game with a stack of cards. She must pull the same cards in a row. So if she has ace is 1, ace 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, and she's got to pull the same card. If she kept that same card, she only has 3 left in the deck. So it'd be smarter for her to replace it, to put it back, so that way she's got 4 aces, 4 2s, 4. So my example would be if she pulls a card and it's a 2, 2 of hearts. then the only other the only other twos in there are the two of clubs, the two of diamonds, and the two of spades. She takes this out, she should put it back in, so that way she has 4 chances instead of 3. All right, so in order to win the game, Lily should replace it. Because pulling it out, leaving it out, will subtract 1 of that type of card in the deck. Does that make sense? Okay. Letter 4. In a cage at the San Diego Zoo, there are 3 black cats. Okay, I'm going to underline this so I'm paying attention. 3 black cats, 4 white cats, and 2 brown cats. Okay. What's my total? That's my first thing I always go to. 3 black cats, 3 plus 4 plus 2. So 3 plus 4 is 7, 8, 9. So my out of is 9. My whole is 9. Okay? Now, in a cage, so then what is, if 2 cats escape from the cage, what is the probability that both cats are black? Okay, well, first of all, they have 3 black cats. So, if the first black cat, so there are 3 black cats out of 9, right? So if there are 2 cats that escape from the cage, what's the probability that are both black? So the first one that escapes, there's a 3 out of 9 chance that it's a black cat. Simplified, 1/3, because I divided by 3. So that was the first cat that escaped, right? Now the second cat that escaped, what's my whole? It didn't come back. So what's my denominator going to be? Okay, well now I've got 8 cats. Okay? And if that first one was a black cat, now there's only 2 black cats left, right? So my second one, I've got 2 black cats. First cat, second cat. Okay? Now I'm going to multiply straight across. So I'm going to go 1/3 times 2/8 straight across. 1 times 2 is 2. 3 times 8 is 8, 16, 24. Simplified, divide by 2. If I do it to the top, I do it to the bottom. 1/12 of a chance that both of those cats are black. Okay? Now, did you see why I did that? It's a dependent, a dependent situation, right? Because the first cat never came back. So then I was down to 8 cats, right? You know that monkey's jumping on the bed? That hole goes down every time a monkey falls off and bumps his head. Just like the cats. Every time a cat leaves the cage, it's not coming back. If you're a cat and you're in the zoo and you become free, you're not going back to the zoo. You're going to explore. Haven't you watched Zootopia? All right. Number 5. Lucas has a bag of 7 blue Skittles, 9 purple Skittles, okay? 7 blue, 9 purple, 5 yellow, and 4 green Skittles. If Lucas randomly selects one Skittle, stop for a second. What am I going to make you do? Find the whole. All right? So I've got 7 plus 9 plus 5 plus 4. All right? And I'm just going to check to make sure I got that in the middle. Sorry, guys. All right? My whole is out of 25. Right? So he's got 25 Skittles in that bag. Now, if Lucas randomly selects one Skittle and eats it, and randomly selects a second Skittle and eats it. So, first pull of the Skittle, second pull. Now, let me ask you this. Is this a dependent or independent? Is he chewing up that Skittle, spitting it back out, and putting it back in the bag? No, he eats it. So, the second pull, the first pull is out of 25. The second pull is out of 24, right? because he takes a Skittle and eats it. All right, so if Lucas randomly selects one Skittle, what's the probability that the first Skittle was yellow? So let's look. Yellow Skittles, how many? 5 out of 25. And the second Skittle was green. How many green Skittles do I have? Now, say I pulled one of my yellow Skittles on that one, it would turn to 4, but that doesn't really matter because I'm going for green next. All right, so here's what I'm looking at. All right, now I can simplify both of these right away, or I can multiply them. I'm going to show you both ways. 5 25ths, 4 24ths. Okay, so first, if I simplify, I'm going to say, well, a 5 and a 25, I'm going to pull a 5 out of the top and the bottom. So that becomes 1/5, right? 5 divided by 5 is 1, 25 divided by 5 is 5. Okay, now this one, I'm going to pull a 4 out of both. 4 divided by 4 is 1, 24 divided by 4 is 6. Okay, so my first pull times my second pull. I end up going 1/5 times 1/6. And that's going to go straight across. 1 times 1 is 1. 5 times 6 is 30. Okay. Now I'm going to show you the other way. I'm just going to multiply straight across, and I'll have to simplify later. 5 times 4 is 20. 25 times 24. Let me bring that bad boy out. 25 times 24 is equal to 600. Divide by 20. If I do it to the top, I do it to the bottom. 20 divided by 20 is 1. 600 divided by 20 is 30. Either way, you can do it, but that's what you're going to end up with. What is the probability that the first Skittle was yellow and the second Skittle was green? The 1/30th of a chance, right? So does that make sense? The main thing that you need to walk away with is that independent, where the denominator stays the same because you're putting the thing back, or dependent, where, hey, that Skittle's getting eaten, so my denominator changes. All right? 7th graders, I hope that helps. Sorry for my little blunder up here, but I think it was helpful because then we kind of were able to talk through it and really understand it. All right? See you later today at Zoom.